Hi, welcome back to Data Science with R by Eduonix. In this tutorial, we're going to be covering methods of importing data. So we're getting pretty close to being able to actually start some modeling and do some more interesting things. For the contents of this tutorial, we're going to be covering built-in data sets, importing tabular data, as well as non-tabular data from text files, JSON, and reading binary data. As for the built-in data sets, R and some of the third-party packages have built-in data sets that are quick and easy to access within RStudio. And overall, they offer a wide variety of data sets to play with, and they're generally useful for either practice or testing new models. In the table on the left here, we have just a few examples of some of the data sets that are available. We have the Johnson & Johnson set, which gives you quarterly earnings per Johnson & Johnson share over time. We have puromycin, which gives data on the reaction velocity of an enzymatic reaction. The Titanic set, this one's actually really popular. You've probably seen this on Kaggle if you've been on there. There are survival of passengers on the Titanic. So this one overall just gives you a lot of information about all the different Titanic passengers and whether or not they survived. And then we have a cars set, which gives you speed and stopping distances of various car makes and models. And then the Morley set, which is data for a Michelson-Morley experiment for speed of light. And importing from table data. All right, so for this, we're mostly looking at CSV, TSV, and text. So not the text not to be confused with the non-tabular text data we'll be looking at. So CSV would be comma separated values, TSV they're tab separated, and then the TXT those can include many different types. So that could be either semicolon, white space, like one or more white space, things like that. Also sometimes separated by a pipe, and could be just about anything. So we're going to be taking a look at these and how to handle some different scenarios that come up with that. And for the non-tabular text files, we still have the same table up there with the CSV, TSV, and text, so go ahead and not assume that's what we're doing here. What this actually is for, why that table is still there, is for a comparison. So that table is tabular data. We have things that fit very nicely into rows and columns, whereas the non-tabular text files, we might have things like item lists, logs, or metadata. We could have multiple tables of different shapes and sizes inside of one file. Any number of different things can come up, any number of scenarios. So on the bottom left, we have an example of an item list. So this, we have these IDs 1, 2, and 3, and then we have these different lengths to each record here. And so if we wanted to import this into a table, because we don't have the additional commas to just indicate, for example, null values, these are actually, they don't have any particular order, they're not particular columns. So all we have are a certain number of items that can vary from ID to ID or from record to record. So that's just one small example of a comparison between tabular and non-tabular from our text files. And for JSON, JSON, if you're accustomed to Python, you may already know what this is. If not, it is essentially just like a set of nested dictionaries with key value pairs, where the values can be a number of things. They can either be numbers, character strings, or arrays. Also, we could call them lists, as well as nested dictionary items or nested JSON objects. So on the left, that's just an example of a small piece of JSON that we'll be dealing with, or we won't deal with that one particularly, but that's just a small example. So JSON, we'll call that semi-structured data because it's not entirely structured, but it's not really unstructured either because it does have some organization to it. And then reading binary data. There can be a lot of different sources of binary data, like audio or video, also images. A lot of applications store their documents or whatever types of objects they may save as binary data. We may also have arrays. So for example, we could have a matrix that may have been stored as binary, and also encrypted or compressed data may be stored as binary. And on the left here, you're just seeing an example of a byte array. So if you were to open up a binary file in a code editor, you may see something like this on the left. All right, so that's just a brief introduction before we move on to RStudio and take a look at how to import these different data types. Okay, with RStudio open, we're going to start off with the built-in data sets. And first thing that we want to do is if you run the line or run the command data with close parentheses and no arguments, then we end up, I'm actually going to type this down here instead of just running that line so you can see, if we hit enter, we get a new tab in RStudio that gives us a printout of all the different data sets we have and just some of the brief descriptions. So that table that we had in the slides, I got those descriptions and names directly from this, so I just kind of picked a few of them that looked like it offered a little bit of variety. And so this is just a good way to know what data sets you want to pull in. Okay, so going back to our importing data.r file, we're going to load a few data sets. So if we want to load a data set from these, what you're going to do is you're going to pass one of these names as a string to the data as an argument. So in this case, we're going to load data, or we're going to load data, yes we are. We're going to load the sunspots data set. So just hit Command Enter there. And you'll notice that on the actual console output, we don't see any data. What that does is it loads the data set into our global environment. So in the upper right here, we can see sunspots. And now if we were to actually type in enter sunspots, it would print out all of the data for sunspots. So this here is a time series. So now that we've actually run sunspots, we have the actual output over here. Before, if you went back in the video, you'd notice that that said promise. So really it's just a promise to have values there. So now that we've run sunspots for the first time, and by the way, the actual variable name comes out to be the same as whatever the data set name is. So in this case, it's sunspots. And so you'll see that this is a time series with almost 3,000 records. And then we also get a little bit of a description in there. Okay, so we can now access sunspots just by calling it. And if we want just the head of the data set, for example, this right here is going to give us, by default, the first 6 records in sunspots. And since this is a time series, if we were to look at this, we'll notice, first of all, we have this nice structure of all these months in this time series. And this time series right here is actually not a two-dimensional array per se. This is just organized nicely for us. Whereas if we go back and look at the head, we'll notice that the first 6 values are these values right here. So instead of being 6 records or 6 rows as it would appear here, we actually get the first 6 records because it's just a one-dimensional time series. So these will match up with that. So they've essentially just laid it out in a nice condensed way for us and given us month values. All right, so another data set, we're going to load hair eye color. So this one, again, here we have that promise up in the values. Let's go ahead and actually show this table. So we'll see this one right here, and we notice that we have what appears to be an ND array, or a 3-dimensional array. So we have sex, male and female, we have hair color and eye color. And this here, this particular type, if we were to do, let's do class. And this one is called hair eye color. So we'll see that this is the class table. So in our basic data types, we didn't cover this because this isn't one of the basic data types. This isn't one of the fundamental types. It actually is built on the ND array. And we'll have the table type when we have contingency tables like this, which we'll learn more about later. Okay, let's see. So we can also output a data set directly to the console if we wanted to. And we do that by calling the data set instead of just loading it into the global environment. So let me show you what that looks like. We're going to call rm hair eye color just to remove that from the global environment. So we can see in the upper right that it's now gone. So we're going to call hair eye color again anyway, and that gives us this actual output. All right, so also, once more, that did not go into our global environment. What we can do is we can actually do different things with this. It can be handy just because either A, we want to see the data set, without loading it to our global environment, or B, we may want to get different subsets of it without loading the whole thing into our global environment. We also may want to